let's talk about what a Shiny app actually is. When you're ready to create a new app, blessedly, thank you RStudio, they just make it so simple. You can go right to the new button in RStudio, click Shiny web app. So that's this screenshot. Then this box will come up. You give your app a name. You can choose if you want to use a single file, app.r, or multiple files, one for your UI, one for your server, and more on that in a second. So for now, let's maybe select a single file and call the app something meaningful to you. And if you want to start coding along, you can. So file, Shiny web app, example app. I'm not going to push. So this is what that creates. I now have, oh, I created multiple files. I did not want to do that. I'm actually going to delete it. These are the dangers of live coding. I just want one. Okay, so now I have an app.r file. It's in this example app folder that gets created in my directory. The nice thing is also that this example app is really well commented. You can see RStudio directs you right to that website I told you about, and then tells you run the application by clicking the Run App button above. And if I do that, it brings up, like I said, this is the example app. It uses this slider input where you can select the number of bins for this histogram of the frequency of eruption of the Old Faithful geyser in Yellowstone National Park, which I think is it's in a state in the US, maybe Wyoming, I can't remember. But this is the example app, and the example app has, so it's the default. One thing I showed you guys run app. The other thing, this is a trick I was taught at my last job. You can also run an app if you're clicked inside the file. You can hit, I'm on a Mac, Command Shift Enter. So whatever the equivalent is if you're on Windows or Linux, that also will run the app. Just that trick changed my life. And so that's our example app. Let's look at some of that code. So our app has a UI. The UI, that stands for the user interface. It's created with the fluid page function, which is just a Shiny function. And we can see that we have a title. The app, if you remember looking at it, has a sidebar over here where that's where the inputs are. So we can see a sidebar layout with a sidebar panel, our slider input. Our main panel has our plot. And then down in the server, you might recognize some of this as just regular R code. This is where the actual plot gets built. This is just built-in data. So there's no data being imported into this app. So like I said, we have our UI. We have a server, and at the bottom of the server, there was this call, because we used one single app.r file, there was this call to Shiny app, which actually runs the app, where you have to pass in the UI and the server you built. And those are the basic building blocks of any app. That's all we need to get started. Let's talk a little bit in more detail about those parts though. The UI, like I said, the user interface, this is the part of the app where you're gonna control the things the user is gonna see and interact with. So this is where you're gonna put the code that will display your inputs, your outputs, any change you're going to make to your layout, so the different tabs, if you're going to change the color to anything, themes, stuff like that. So anything that's going to affect how the app looks is going to end up in your user interface. The server function is going to create a new environment every time you start the app. It technically requires these three arguments: input, output, session. You're not going to create any of those things. Instead, inside that server, you use any inputs that you built as needed to create all the things you want to display. So your plots, tables, you do maps, value boxes. There's a lot of options for things you can display. You're actually going to build those in your server. And then I just want to introduce, again, very reductive, the most basic definition of reactivity, because reactivity is really core to what Shiny is. We're doing reactive programming. Reactivity fundamentally just means that when your inputs are updated, they automatically update any outputs they're connected to. So with our Geyser app, when I change that slider, the histogram changes. Changing the slider changes the input, the number of bins, then that output gets updated. That's reactivity. Reactive sources are those inputs themselves. So in our example, like I said, the slider, number of bins. Reactive endpoints are the things that are updated by the reactive sources and are going to appear to your user, that histogram in our example app. You can use these ideas put together and you can build inside of apps, and as long as we have time, I'm going to build one and show you when it's useful. You can build a reactive expression, and a reactive expression is a function, but it's only evaluated when called by a reactive endpoint. So it has to be, it's reactive. You build it inside a render function, or you call it inside a render function, this function. And it's evaluated only when that reactive source changes, when an input changes. Otherwise, it's just cached, lazy, it sits there, nothing happens. That's truly just like the most basic idea of reactivity. It can be a difficult concept. It definitely took me a long time to wrap my brain around it and then even to explain it. And there's a lot much better explanations on the web than I will make you suffer through. So just keep that general idea in mind. When you change an input, that output gets updated. So let's talk about our app. We're going to build a Tunisia themed app. There's some data from the website Statista that has some economic data. So it includes, we're actually going to recreate this graph here with the share of economic sectors in GDP from 2008 to 2015. It gives the share for agriculture, industry, and services. But there's some other data as well. So let's go look. This code is in the GitHub repo if you're there. But it also, I also cleaned it up the data and wrote it back out. So we're going to use the cleaned version, but I'll show you what's in there. The raw version of the data gets read in from an Excel sheet, and so it looks kind of ugly because you can see there was this note a few rows down. So I end up with all these empty rows that get read in. As a result, I cleaned out anything where there was an NA in the year. That gives me the actual data. So now I just have the data. I do notice that I have an NA on 2008 with the growth rate. That'll be important later. I wanted year to be a factor, and I changed agriculture to be a double because eventually it's not, for reasons unknown. And then I wrote this out. Another cool thing that I used, if you look on the raw data set, the original names on the data set were a lot of spaces, percent signs, all that. If you've never used janitor clean names before, it's really nice. It'll take you from these kind of ugly names to really nice snake case names. So I highly recommend the janitor package and the clean names function. So we're going to work with this data that has the growth rate of the real GDP. Then it has that share data for the GDP, agriculture, industry, and services. Then it has a bunch of different economic indicator percents for each year. So the population growth, infant mortality rate, unemployment rate, inflation rate, and fertility rate. So it's not a huge data set, but it's definitely enough for us to build something. We'll recreate this plot, like I said, and